A very good morning. In this video, we will be discussing about evaluation of projects using varying cost of capital. Before we could understand the procedure of solving or evaluating problems using varying opportunity cost of capital, let us understand the meaning of opportunity cost. The opportunity cost of capital is the return on investment that a business forgoes when it selects to invest in project A rather than investing in project B. Hence, if the project return of the project A is less than the expected rate of return on a project B, then project A will be rejected, assuming that this is the only basis for the decision. Now let us understand the process of evaluation of projects using varying opportunity cost of capital. We use NPV method to evaluate the projects in varying opportunity cost of capital. Now, how do you understand that a problem is based on varying opportunity cost of capital? When a problem has reference of different cost of capital for different years investments or earnings, we identify the problem as varying cost of capital, problem on evaluation of varying opportunity cost of capital. We use the NPV formula to calculate the varying or to solve the or to evaluate the varying opportunity cost of capital. The formula goes like this. NPV is equal to C1 divided by 1 plus K1 plus C2 divided by 1 plus K2 plus. In the same manner, we take it for the number of years for which the cash inflows and cost of capital are given. I mean to say, interest rates are given minus the CO. Now let us see what is C1, K1 and CO. C1, C2, C3, C4, C5, Cn for the indefinite period of cash inflow. We call it as annual cash inflows. The K represents interest rates, the cost of capital given in the problem. And the CO is nothing but the original investment or initial investment. Now let us take up a problem on evaluating using varying cost of capital. The problem is ABC firm is considering the purchase of machine. It has two alternatives A and B, each costing 50,000. Consider for all evaluation the expected earnings after taxation. So the cash flows are given. The cash flows are nothing but here it is the cash inflows. And also the cost of capital is given for every year. In this problem, you could see that the cost of capital is floating. It is different every year. So this problem is identified as evaluation of project A and B or machine A and B using varying cost of capital. So the problem is asking you to evaluate the machines A and B by using NPV method. So as I told you, we are going to solve this problem using the form NPV method only. But the formula we go by using the formula method. We don't use the formal NPV of calculation. So this is the formula that we have. Now here we have project A or machine A cash flows are given and machine B cash flows are given. So we need to calculate the cash flows for machine A and machine B separately. So NPV is to be calculated for both A and B separately. So first let us calculate the calculation of NPV for A and B. So let me increase the font size. So first step, calculation of NPV for machine The formula is NP is equal to C1 divided by 1 plus K1. So 1 is constant here that we have to remember. Let me take it. So NPV is equal to, we are talking about only machine A. We are calculating the NPV for machine A. So let us take the cash inflows of A and the cost of capital remains the same for both the machines. So the first year cash inflow C1 is how much it is. Let me take to the single page so that it becomes easy for solving. Okay. So we're calculating the NPV for machine A. So here supposed to calculate C1. C1 is the cash inflow of first year. So it's going to be equal to 15,000 divided by 1 plus K1. K1 is your cost of capital. Cost of capital is 10%. 10% can be rewritten as 0.1. It's going to be the bracket. Okay. Next, plus C2. C2 is your second year cash inflow. Second year cash inflow is 20,000 divided by 1 plus cost of capital is 12% for the second year. So it can be rewritten as 0.12. C3, because we have 3 years. So n number of years. So how many years we have? That many years we need to calculate the present value of cash inflows. Minus the original investment will get you your NPV. In NPV method, we do use columnar method, but here we are using the formula method. That's it. So for the third year, our cash inflows are how much? It is 25,000. 25,000 divided by 1 plus 1 is constant. The cost of capital is 15%. So 15% is rewritten as 0.15. Yes. We have fourth year cash inflows also 15,000 divided by 1 is constant. 0. The cost of capital for first, second, third, and fourth year. Fourth year is 12% again. 0, 1, 2. We have 1 more year, so it's going to be again plus cash inflow of fifth year is 10,000 divided by 1 plus cost of capital is 10%, so it is taken as 0.10 minus your CO. CO is how much? Original investment. Your original investment for both the alternatives is 50,000. It is same. So minus CO. CO is 50,000. When we simplify this, we'll be getting. You have to simplify each cash inflow. So 15,000 divided by 1 plus 0.1 gives me 13,636. You need to simplify. First, you need to remove the brackets. You have to use BODMAS here. So remove the brackets first and then the division. And then we need to add it. So the second 20,000 divided by 1 plus 0.12 gives me 17,057. 25,000 divided by 1 plus 0.15 gives you 21,739 plus 15,000 divided by 1 plus 0.01 13,392. plus 1000 divided by 1 plus 0.1 gives you 9091. And this should be minus with CO is 50,000. 75,715. That is 13,636 plus 17,857 plus 21,739 plus 13,392 plus 9,091 gives me 75,715 minus your original investment. So your NPV is equal to, so NPV of A is equal to 25,715. So we are getting a positive NPV. So similarly, we calculate the NPV for machine B. So we calculate the NPV for machine B. Here we have the cash inflows are going to vary, but your cost of capital remains the same. So I take the same thing, but I will be changing only the cash inflows. NPV is equal to only your investment changes. So investment is 5,000, 15, 20. So it's 5,000. 30,000 and 20,000. So 20,000 minus your original investment, it is same because the problem mentions that it has two alternatives A and B, each costing 50,000. That means both A and B has the same cost. So when I simplify this, NPV equal to 8,000 divided by 1 plus 0.1 is 4545 plus 15,000 divided by 1 plus 0.12 gives you 13,392. 20,000 divided by 1 plus 0.15 gives you 17,391 plus 30,000 divided by 1 plus 0.012 gives you 26,785. Last year cash inflow present value is 20,000 divided by 1 plus 0.10 gives you 18,181. This is the present value of all your cash inflows with varying cost of capital minus your original investment 50,000. So NPV is equal to, the total of the present value of cash inflows is 80,294 minus equal to NPV is how much? 80,294 minus 50,000 will be 30,294. We got the NPV of machine A and machine B. So now, how do we make a decision? Now, the comment would be, analyzing the NPV of both A and B. So NPV of A is NPV of A. Equal to 25,000 and machine B NPV is how much? 30,294. So machine B NPV is 30,294. Now, which one do you recommend? The net present value of cash inflows of A is 25,715 and machine B is 30,000. 294. So we have both positive NPVs. So always a positive NPV is acceptable. But when you're comparing two different machines, we always suggest or recommend machine B as a higher when compared to machine. Would be the conclusion what you're going to get. Okay, so your comments would be given on comparison with A and B. Compare the NPVs as they are positive. A higher NPV is always accepted. Thanks for watching this video. Meet you in the next video. Thank you. Have a nice day.